Hello, fellow astronomers. Jonathan here. I'm back at the Besser Museum Planetarium today to talk to you about the universe's smallest star, or at least something really close to it. As you probably know by now, the universe is way too big for astronomers to look over every single star, measure them, and then compare them all against the other stars in the universe. After all, with a very rough estimation of about 2 septillion stars in the entire observable universe, astronomers wouldn't have the time or the technology to properly examine them all. Well, in lieu of actively trying to measure all these stars, astronomers can instead rely on the laws of physics. Believe it or not, what is and isn't a star can be kind of controversial among astronomers. But just to keep things simple for today, we'll simply define a star as any object massive enough to cause sustained nuclear fusion in its core, where you can think of mass kind of like an object's weight. Nuclear fusion is the active process of forcing elements together and creating new ones. This is able to happen because stars are really, really massive, and their core experiences intense heat and pressure as a result of the several septillion tons of star pressing down on it. This then causes the atoms in the core to collide and create new elements. The smallest type of star that can do this is called a red dwarf. Finding a red dwarf star that is small enough and dim enough to match this criteria is no easy feat though, as these stars are already really small and dim, and now astronomers are looking for the smallest and dimmest of that bunch. Thankfully though, red dwarf stars are the most common type of star in the entire universe, so astronomers didn't have to look very far to find a good candidate with only a few dozen light years of Earth. Among all of these stars, there was one that really stood out amongst the bunch. Or should I say, didn't stand out? And this star that was found has a very messy name, and it goes by the title of 2-mass J0523 TAC 1403. For the sake of convenience though, we'll simply call this star 1403 from here on out. In terms of actual size, 1403 was measured to be about the size of Jupiter, and maybe just a little smaller than it too. Don't let 1403's size fool you though, as it may be small, but it's still a star, which means it's still around 68 times more massive than Jupiter is. While 1403 is small for a star, it's still much larger than Earth is, especially since Jupiter has a radius about 11 times bigger than the Earth, and you could still easily fit over 1,000 separate Earths inside of it. And since 1403 is about the same size as Jupiter, we can see that even a small star makes our planet look insignificant in comparison. And with 1403 being about as small as stars get to, this means you're not going to accidentally stumble across it or any comparably small stars the next time you look for the TV remote in between your couch cushions. While our own star, the Sun, is far from a giant, which you can learn about in my largest star video, it is still noticeably larger than 1403 is. In fact, the Sun is about as big to 1403 as 1403 was to Earth. It's not exactly the same ratio, but you could still fit 10 stars of equivalent size to 1403 across the Sun's equator. This makes for a striking visual where our smallest star is now a fraction of the size of our Sun, while the Earth is barely a discernible pixel on the screen. Alright, fellow astronomers, that's all I have for you today in terms of information. Before you go though, I have a question for you. If you were in charge of naming 1403, what would you call it? Make sure to leave your answer down below in the comments so I can read them all. Until the next time though, keep your eyes on the stars.